I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture number 26, we will briefly discuss about the reachability in 5G. That is, what is reachability, how we are using it in the 5G. In 5G networks, reachability ensures devices are accessible anytime, managing energy efficiency and quick reconnections through paging and network slicing. Mobility management maintains uninterrupted connections for moving users, handling transitions between cells with a smooth handovers and dual connectivity. These mechanisms support stable, high speed communication even in dense or high mobility settings like cities and transport. Together, they make 5G networks highly adaptable and reliable across diverse scenarios. Next, we should know what is reachability. The reachability in 5G networks refers to the network's capacity to accurately determine the status and location of user equipment, that is UE. This involves identifying whether a user equipment is active, ideal, or unreliable, allowing the network to manage communication effectively. The ability to track user equipments in real time is important for ensuring efficient resource allocation and timely data delivery, especially when user equipments transition between different states. And the importance or the reliability plays a vital role in managing user equipments, and particularly those in ideal mode, especially in the ideal mode where they are not actively communicating but still need to be reachable for incoming calls or messages. So one more time I'll tell you, the reachability plays a vital role in managing what user equipments, particularly those in ideal mode, especially where they are not actively communicating but still need to be reachable for incoming calls or messages. By ensuring that these networks can effectively locate and communicate with these user equipments, reachability enhances the user experience and facilitates the important communication. It is especially important for critical applications like emergency services, where accurate and timely information about user equipment status can significantly impact response times and service effectiveness. Next, the key mechanisms used in this reachability is the paging. Paging is a critical mechanism in 5G network designed to locate ideal user equipment, that is UE, when data packets are received for them. Since ideal user equipments do not maintain the dedicated communication link, the network must actively search for them to establish a connection and deliver the incoming data. When the user plane function, that is UPF, receives a download packet for an ideal user equipment, it triggers a paging request which prompts the access and mobility management function, that is AMF, to send a paging message to the appropriate area. This process ensures that user equipments can be quickly identified and connected, maintaining efficient communication and resource utilization in the network. Next, event reporting. Event reporting allows the network to monitor user equipment mobility and status dynamically, and the authorized network function, that is NFs, can subscribe to receive update on specific mobility events such as when a user equipment enters or exits defined areas of interest. This capacity is important for maintaining an accurate understanding of user equipment locations and movements, which enables the network to make informed decisions regarding resource allocation and service delivery. By tracking these mobility events, the network can enhance service quality, optimize performance, and ensure that user equipments remain reachable when needed. And the real world applications are the mechanism of paging and event reporting have significant real world application, particularly in emergency services and real-time location tracking. This is very, very important parameter. For instance, in emergency situation, quick access to user equipment's location and status can drastically improve response time and effectiveness of services. Similarly, real-time location tracking is vital for applications like fleet management and asset tracking, where accurate and timely information about user equipment is essential for operation efficiency. These applications demonstrate how effective reachability and mobility management can enhance safety and service delivery in various contexts. This is highly possible in 5G networks. Next, what is paging? Paging is a mechanism in 5G network specifically designed to locate ideal user equipment and establish a signaling connection when it is needed. In the context of mobile communication, ideal user equipments those that are not currently engaged in active data session or calls. When a network needs to reach these user equipment, such as when incoming data packets arrive, and the paging mechanism allows the network to send a request to locate and wake up the ideal user equipments. If it is ideal, means so it is used to wake up the ideal user equipment. This process is important for maintaining efficient communication and ensuring user equipment can be reached promptly when data needed to be delivered. The purpose of this paging is the primary purpose of paging is to facilitate communication with user equipments that are not actively engaged in session, particularly when downlink packets are arrive. In 5G networks, when data is intended for an ideal user equipment, the network must identify and connect with that user equipment to deliver the data. Without the paging mechanism, these user equipment would remain unreachable, leading to delays or failures in communication. By effectively managing how and when to page user equipment, the data network can optimize resource usage and improve overall service quality, ensuring that users receive timely notifications, calls, or messages even when their devices are not in an active state. Next, the triggering event. The paging process is initiated when the user plane function, that is UPF, receives the download packets designed for the ideal user equipment. Since these user equipments are ideal mode, they do not maintain a dedicated communication link, and the user UPF lacks an NG or an user plane tunnel address needed to deliver the packet directly. This lack of an address means that the UPF cannot immediately send the data to user equipment, prompting the need for the paging mechanism to locate the user equipment and establish the connection. By identifying the download data in pending for an ideal user equipment, the network can initiate the process to ensure timely delivery. And what is packet buffering in this paging is upon recognizing that download packets are intended for an ideal user equipment, the UPF buffers the incoming packets instead of discarding them. This is very, very important property. This buffering is an important as it allows the network to temporarily hold the data until the user equipment can be located and connected. Additionally, the UPF notifies the session management function, that is SMF, about the pending downlink data, signaling and that action is needed to facilitate the delivery. This collaboration between UPF and The SMF is essential for managing resources effectively and ensuring that user equipments can receive the data promptly once they are reachable. Next, setting up user plane resources and the communication with the AMF. The first point is when the user plane function UPF identifies that download packets are pending for an ideal user equipment, it collaborates with the session management function to set up the necessary user plane resources. The SMF requires the access and mobility management function, what we are calling it as AMF, to establish these resources specifically for the protocol data unit session linked to the incoming data. This communication is essential as it ensures that the network can manage resources effectively and prepare for eventual connections with the user equipment, enabling a smooth transition from ideal mode to an active communication state. And how we are going to locate the information as part of the resources. See, setup process, the AMF plays an important role in identifying the registration area that we are calling it as RA, where the ideal user equipment is located. This location informing is vital for formulating an accurate paging request to the next generation radio access network, NG-RAN. By pinpointing the user's RA, the AMF can optimize the paging process, ensuring that the request is sent to the appropriate geographic area. This targeted approach not only increases the chances of successfully reaching the ideal user equipment, but also enhances the overall efficiency of the network by minimizing the unnecessary paging attempts in area where user equipment is not present. Next, paging execution and summary. The first point is paging occasion calculation. The next generation radio access network that we are calling it as NG-RAN is responsible for determining the optimal time to page the ideal user equipment. This calculation is based on the portion of the user equipment's 5G temporary mobile subscriber identity 5G STMSI, which helps the network identify specific paging occasions. By leveraging this identifier, the NG-RAN can ensure that the paging message is sent at a time when the user equipment is most likely to be reachable, thereby increasing the chances of successfully establishing a connection. This systematic approach to the timing is critical for effective resource management and minimizes the impact on network performance. And the paging response, coming to the paging response, once the paging connection is determined, the NG-RAN sends the paging message to the targeted UE, user equipment. Upon receiving this message, the user equipment responds to the access and mobility management function, indicating its readiness to connect. This response signifies that user equipment is prepared to transition from ideal mode to an active state, allowing it to receiving the pending downlink packets. The exchange of messages during this phase is essential for establishing the communication link needed for data delivery. So this is also very, very important. And coming into the activation, this following the user equipment's response, the AMF activates the user plane resources required for pending downlink packets. This activation involves setting up the necessary data paths and communication links to ensure that the buffered packets can be forwarded to the user equipment without delay. By efficiently activating these resources, the AMF not only facilitates immediate data delivery but also optimizes the overall network performance, ensuring that user equipment experiences or important communication even when transitioning from ideal active states. And coming into this paging execution and the summary, paging is a critical mechanism in 5G network that effectively locates ideal user equipment, optimizes the network performances for the seamless communication. By calculating the right timing for paging, sending targeted messages, and activating user plane resources promptly, the network ensures that user equipments can be reached efficiently, enhancing the user experience and maintaining high service quality. This streamlined process is essential for managing dynamic nature of mobile communication in today's world. Next, the overview of MICO mode. That is, MICO means a mobile initiated connection only. MICO, we are calling it as MICO or MICO. MICO mode is a feature in 5G network designed to optimize resource utilization. How we are going to optimize the resources? By minimizing paging for user equipment that does not need to be available for mobile terminating communication. In this mode, user equipments are recognized as only initiating connections, allowing the network to conserve resources and focus on those user equipment that required constant availability for incoming communications. And the coming into the behavior of MICO mode, when a user equipment MICO mode, and enters the connection management ideal state, the access and mobility management function treats the UE as unreachable. This is also very very important. This means that the network will not attempt to page the user equipments for incoming calls or messages reflecting in status or not actively needing to the to maintain a connection for terminating communication. This behavior is, instrumental in reducing unnecessary network traffic and resource allocation for user equipment that are not expected to receive the data. And coming into the use cases, MICO model is not suitable for all types of UEs. For instance, UEs that may initiate emergency services cannot indicate a performance preference for MICO mode during the registration process. This ensures that the important communications remain prioritized and reachable at all times, reinforcing the necessity of maintaining connectivity for emergency situations. Therefore, while MICO mode offers advantages in resource savings, it must be applied selectively to ensure the reliability and availability of service for all users. Next, coming into the that is negotiation and paging area. In 5G, MICO mobile initiated connection only mode is negotiated during the registration process. The user equipment can indicate a preference for MICO mode, but the final decision is made by access and mobility management function based on factors such as the user equipment's preference, user subscription details, and the network policies. When MICO model is enabled, the paging area for the user equipment it is expanded, and the registration area is no longer constrained by using paging area size. If the AMF has control over the entire public land mobile network, PLMN means what? PLMN means public land mobile network. It can assign an all PLM. See, all PLM RA to the user equipment, further broadening its reachability across the network. Next, location services. So 5G supports location services similar to EPS, allowing any authorized network function enough to subscribe user equipment mobility event. This enables precise tracking and is beneficial for applications like emergency services and navigation. Real-time data from these services enhance user experiences and the subscriber information. And the subscription option is 5G location service allow reporting and UE location or mobility in specific areas of interest. This targeted approach helps deliver essential data while minimizing network load. It provides efficient support for applications and requiring continuous monitoring. Next area of interest. The area of interest can be specified by tracking areas, calls, and NG-RAN nodes. For LADN application, the NF provides LADN DNN, and the predefined areas can be assigned unique identifiers. And this helps focus resource on relevant zones for location data. Next, event reporting detail. Event reporting can be set up with periodic updates, report limits, and specific connections like movement into specific areas. This customization enables timely, resource efficient, and delivery tailored to the needs of each application. Next, the notification address. It address on the NF for notification can differ from the subscribing networks. Next, target of event reporting. The event reporting can target a specific user equipment, a group of UEs or calls UEs in a network. This flexibility helps in customizing reporting based on application needs like tracking individual devices or monitoring groups in emergency situations. And location accuracy. The AMF and NG ran to obtain accurate location information with the UE needing to be in CM connected and RRC connected states. High accuracy or at the cell level is essential for critical services like emergency response and lawful interception. And presence reporting enables the AMF to define up to 64 areas of interest. Tracking by NG ran using TAs, cell identities, node identities. This feature supports monitoring UEs as they enter, exit specified zones. It is valuable for applications in public safety, logistics, and IoT. And coming into the conclusion, the described approach, that is paging and everything, ensures that devices maintain constant accessibility while optimizing power efficiency and connection speed. By employing paging mechanisms and network slicing, it enhances reachability across diverse applications. This solution is particularly beneficial in high density or mobile environment such as urban areas where reliable high speed connectivity is essential. Ultimately, it significantly improves user experience and the service quality, which is critical or important for IoT applications, emergency services, and connected vehicles. Thank you all for joining me in today's session on reachability in 5G. I hope you found the insights valuable and enjoyed exploring this important topic together. Your engagement made the discussion even more enriching for me. I look forward to seeing you in my next lecture where we will continue our journey into the world of technology. Until then, take care and keep exploring. Thank you once again.